everyone, hope you're all doing well. Thank you so much for watching my videos. This video we are going to continue our discussion on machine learning and programming. This video is in a series of videos where we are talking about various machine learning foundation concepts. Okay, last video we just grazed past the password and the face detection dilemma. So what are the three areas where we thought we should be using machine learning was: first was the speed, the second was the scale, and third was the cost. These are the three areas we saw where we should be using machine learning and not programming. Okay, so coming back, let's dive deep into this dilemma of password and face detection. Why we need programming, why we can use programming rather for password, and we need machine learning for face detection. Let's jump into the video. The case of two identities. What are the two identities? One is the password and one is the machine learning where we are detecting the face. Okay, so the problem is the same. Both the places we are need to give authentication to the user to get into the system. Okay, but somewhere we are using the passwords and somewhere we are using the machine learning algorithm to detect the face. Okay, this password, as I mentioned here, is rigid and exact, and the exhibit B is the face which is fluid and changing. Okay, the same face, it is not, if you see there is a face, maybe you can identify, but for the machine, every lighting, every hair change, everything is one separate face and it is not the same face. Hence, every minute you can have 3-4 faces of the images which the computer has to take. So that is why this is called changing. You might think, why the face is changing? It doesn't change at all, but for the machine it is changing because every photograph, it will take it as a photograph and compare it with the photograph which is given inside. In case of password, what happens? There is a password 1, 2, 3. Okay, so what you need to do is whenever you enter 1, 2, 3 exactly, it even sees the case when you are writing capital and small, if you have mentioned, if you have noticed. So if it is exactly matching, then in that case it allows you. For in case of face, you cannot just put one photograph of yours and it tell it to match the face exactly, which is not possible. Okay, so that is why the question here is, why does one need code and the other need AI? Okay, so what I was explaining is the face is changing continuously. Every hair flying, every blink of your eye, every lighting change, everything changes the face, and then it cannot match the face with what face it has inside the database. Okay, why logic failed the investigation? Traditional programming has very strict rules. Okay, as I told you in the beginning also, I have told programming is like a straight line. You have A, you have B, you will get C. Okay, if you go a little bit on top also, here or here or here or here, you change A or B slightly, you will not get C. You will get something other than C, and the program might fail. You cannot exactly do the same thing. So the programming has very strict rules, and the problem is you cannot write a if statement for every shadow, angle or a haircut. As I was telling you, you cannot have hundreds and thousands of cases where what we write for the password is if password entered by the user is equal to password in the database, allow. Okay, so this is as simple as that. But in case of face, it is not possible for every shadow, angle and haircut. Hence, we cannot use programming for face detection. Okay, in case of programming, it is very easy. You just input is the secret, unlock, it's unlocked. That's it. It's as simple as that. But in case of faces, you cannot use programming. Okay, the verdict: code breaks when input varies. So as we mentioned here in case, okay, so this is again and again I am going to the same example because it's the easiest example which can explain the thing, where the A, this is the B, this is the C, and if A or B slightly changes, you will not get C, okay, and the programming fails, okay. So the new detective is the pattern recognition. This is what is the difference between machine learning and programming. So what is machine learning going to do? It is going to understand the pattern of the face. If you see shape of the jaw, you give hundreds and hundreds of same person's photograph, it will create its own image of that person in the database to recognize the face, okay. Machine learning is finding patterns. What we saw, the machine learning, the programming in the last slide, programming was strict rules is equal to programming. But machine learning is finding patterns. We don't give rules at all to machine learning, we give examples, that too millions of them. Okay, if you need the machine learning algorithm to understand what you're trying to tell, you give the example. There are two types of learning, how the machine learning actually does. There is the supervised and the unsupervised. Now we will not get into it. We are in the very basic level. So we will just tell when the machine learning learns, we have to give examples. There can be different kinds of examples. We will talk while we are going down. But we have to give millions. The more the examples you give in the correct direction, your examples you give, you will get the correct answer. The output is the probability, not certainty. In case of programming, again that A, B, here you get the C, this is certainty. This is certainty. Okay. In case of machine learning, it is probability. Okay. So machine learning is probability and programming is certainty. Understand? So this is the difference between machine learning and programming. So closing the case, the general rule, when to use code, the rules are fixed, max, password, etc. You go and use the password, this is correct. Okay, and here also this is correct. But in case of machine learning, the rules are too complex. Faces, weather, speech, audio also, weather also, you want to find out the reason, then you have to use the machine learning. So here it is machine learning, here it is machine learning, here it is machine learning. Okay. Final lesson, use logic for accuracy and use ML for ambiguity. Okay. You have an accurate logic, then you use programming. But you have ambiguity, then you use machine learning. Okay. But wait, what do machines actually see? You know why we need machine learning now? Okay, we have clearly explained in this video that why we need machine learning, where the password fails, that ends the programming level, and from there the machine learning starts. But how does it work? How does machine see? Does it actually see I told you, you have to upload the photograph, right? So is it actually seeing the photograph or it is seeing something else? Okay, what you see is this image, this beautiful girl's face. Okay, but what the machine sees is, you can see, these are all the numbers you can see. So this photograph is basically a collection of numbers for the machine, and it is not the same face which is seen by the machine. Okay, so how does a photo become a prediction? You have to convert the photo into numbers for the computer to understand. Okay, what does data actually mean to the machine? When we give a photograph, what does it actually mean? The data, the photograph, what I told, we will upload it. What does it actually mean to the machine? How does a face become numbers? The face has to be converted to numbers for it to understand. So how does the computer convert the face into the numbers? What are vectors, features and metadata? So this is the most important topic, where we convert, or we rather transition from the traditional password level to the machine learning. So this will be your first concept in the machine learning, where we are going to understand what are vectors, what are features, and what are metadata. Okay, so this will be the next episode where we will talk about the data ingredient. Okay, so these are the photo will be converted to this 3 items, and then the computer will be able to get this data. Like you are giving the photograph, how will it assimilate the data? That will assimilate by converting the photographs or any other data you give into these 3 items, so that it can recognize the photograph what you have given it. Okay, thank you so much for watching my videos. So we will see the next video, and we will see what is the data, what is data, and what are parts of the data. We will see in the next video. Thank you so much. Take care. Bye bye.